Hey folks, welcome to my channel Number Pen. There we have the problem on our screen. Find the derivative of the following function with respect to the corresponding independent variable e to the power x sine x, right? So we know that this is a product of two functions. So we may call those functions u and v and write them down, right? So my u of x equals e to the power x and my v of x equals sine x, right? And my f of x, which is u dot v, means that I'm going to apply the product rule of differentiation. So my f dashed is nothing but uv dashed plus vu dashed, right? So let's do that. So my v dashed is d by dx of sine x, and we've already done that using first principles, and I will put a link to that particular video in the description. Please take a look at it if you haven't seen that before. And then I have e to the power x, right? Now I know that my e is Euler's constant, so I'm going to use this particular problem to solve for e to the power x using first principles, right? But before we get there, let's assume that we have a function g of x equals a to the power x, right? Where a is a constant and you may always replace it by e because e is again a constant, right? And where a is a constant, right? And we're going to solve for d by dx of a to the power x, right? So let me write down using first principles. D dashed is nothing but limit h tending to 0 g of x plus h minus g of x divided by h, right? So let's write our expression. We have limit h tending to 0 e to the power, I'm sorry, a to the power x plus h, right? So we have this as limit h tending to 0. What is my g of x plus h? It is a to the power x plus h minus a to the power x divided by h, right? And I'm going to pull out my a to the power x because that's independent of h. And I'm going to write that out separately. And I have my limit h tending to 0. This expression is nothing but a to the power h minus 1 divided by h, right? And this is a very familiar expression if you've done all the exercises under limits. And I'm not going to go into the detail because we know this as an identity or a formula. So my limit h tending to 0, a to the power h minus 1 divided by h is nothing but it is log of a, right? So what is my answer for this particular problem? My answer is, I mean, for a to the power x, right? So it is a to the power x into log of a, right? So again a very useful formula to remember. So d by dx of a to the power x is a to the power x log of a, and when we say log of a, we are referring it to the base e, right? And so what happens when I substitute my a by e, right? So my d by dx of e to the power x, what is that? So let's write that out. All that I'll have to do is replace my a by an e, right? And what is that? It's e to the power x into log of e, right? And what is my log of e? My log of e is nothing but 1, right? So I still have the final answer as e to the power x, right? So my d by dx of e to the power x is e to the power x, right? So now I can go back. I think I have all that I need. So two things we learned in this particular problem. One is d by dx of e to the power x is always e to the power x, and d by dx of a to the power x, again, a useful formula to remember is a to the power x log e, right? So let's go back and substitute it out here. I'm going to pull out my equation. And what is my f dash now? My f dashed is uv dash plus vu dash, right? So what is my u? My u is e to the power x. So I write it as it is. And my v dash is d by dx of sine x, which is cos x. And then I have my vu dashed. My v of x is sine x, so I write it as it is. And then my u dashed is d by dx of e to the power x, which we saw that it is e to the power x only, right? So so this has a common factor. So we can rewrite this particular expression as e to the power x into sine x plus cos x, right? So that's how we go about solving this problem. So the final answer to the problem e to the power x sine x is the derivative of that particular expression is e to the power x into sine x plus cos x. I hope you found this video useful. Please do subscribe to my channel and support. Thank you.